Hello again, my name is Akshar Kumar and I'm back with another video after a long while to showcase a project that I recently completed in my summer break. Specifically, this project was about artificial intelligence and detecting objects with artificial intelligence. Artificial intelligence, or AI, is something that's an emerging technology that I'm really interested in and I really wanted to dive deeper into it. That's why I chose this project, so that I can get some first-hand interactions with this new technology that I'm really engrossed in. Specifically, detecting images with artificial intelligence falls under computer vision, which is an application of AI that really excites me a lot, and I wanted to hone in on that one because of just how cool it is to see it implemented in real life, and because of how many examples of real-world AIs there are that use computer vision. So specifically about computer vision, it utilizes CNNs, or convolutional neural network, which are advanced models or algorithms that are able to parse down an image to detect objects within it and really just analyze images. And so with my previous information or background knowledge on CNNs, I thought this was a pretty doable, also pretty advanced project that I wanted to dive into. And so I'll explain later more about it now. So the goal of my project was to create a computer vision model that could detect Dalmatians within images. And for this project, I used the YOLO model, or the You Only Look Once, which is an advanced CNN that can do object detection in real time within milliseconds. And I also, the YOLO model comes with the DarkNet framework, which is a framework for these sort of AI models. So how did the training go? So I didn't use that big of a training data set, whereas usually computer vision models have thousands of images of training. Because I didn't have that much processing power and I had to annotate all these images myself, I just went with a small set of image data just to see how it would work out. So with only 20 training images, 7 testing images, and 5 validation images, I was able to hand annotate them, which basically means using a software to put like boundary boxes of where a human detects the Dalmatians within the image, so that the model can train itself to see how I did it, so it could learn to follow my pattern recognition skills. And so I hand annotated all of these training images and fed them into the model and trained it for about 10 hours on or off. You could train it for much longer for better results, but at around the 10-hour mark, I realized that it wasn't improving that much, and that was enough really for the model, that only so many training images. So how accurate was the model? Well, you can see examples here of the previous images. You can see it on the left, it detects the 3 Dalmatians, in the center it detects the small puppy, and on the right it detects the one in the center as well. All with pretty high confidence ratings of like 99%, 97%, or 98%, which is a pretty accurate model given how little training it had been given. And if you see these metrics on the side, MAP and IOU, the MAP is 97.78% and IOU is 87.41%. These are pretty high. And if a refresher, you don't know what this means. IOU is intersection over union, which basically measures the percent overlap of the model's boundary box and my boundary box. You can see examples of like the more they overlap, the higher the IOU, which means the better your model is in accuracy. And MAP, or mean average precision, is a little bit more complicated. It just measures like precision versus recall, which are 2 different ways of measuring how accurate your model is. And it shows like, calculates the area under the curve of this model, of this graph. And the larger that number, the more accurate your model is. So if we look back again, like these pretty high numbers seem to allude that my model is actually very accurate. However, if you see here, that's not exactly the case, because only 20 training images, there's not a wide array of Dalmatians and different Dalmatians that the model could see for it to be very robust or acceptable to different types of images. So you can see if I used a Labrador here, which is very similar looking to a Dalmatian, it gave a 98% confidence rate. And if I used a zebra, even more comical, it gave 100% confidence that that was a Dalmatian. And so really, you can see that it's not the most accurate. And here's some more examples. As you can see here, it is able to detect the Dalmatians on the left, but it also tries to detect the guy's shirt as well because of the black and white spots that the model has picked up as a common theme with Dalmatians. And on the right, with a group of many different Dalmatians, you can see that a lot of the Dalmatians are being picked up, but some aren't. And it really just shows that while 10 hours of training and 20 images is a lot, when it comes to computer vision, these are pretty demanding models that need a lot of training and a lot of images in order to be very accurate. And since it was just a passion project, I didn't really try that much of doing that much work or effort into making a model that accurate. But other than that, I think it's just really interesting to see how my model worked out and how it, just to see it in action. It was really truly inspiring when I saw like these boundary boxes getting generated by the model. And as you can see, if I were to, here's the code, it's actually not that much. I'm using it on Google Colab, using just a lot of the trained weights and the data that's already out there on the internet to build on top of existing code that's been made. And as you can see, like here's the training stage, the testing stage. It's a lot of text, but really the brunt of the work just came with just setting up the images and setting up the work, and actually running the model just was waiting really. And so that's just what I wanted to share. Further work really, I think maybe to make the model more accurate, I can tweak some parameters here and there, but that's a lot more complicated and there's a lot more mathematically involved. I could also just train it for longer to make it more advanced. Or I could use a different framework other than YOLO. There's many other open source ones like OpenCV or TensorFlow or really other programming models like MATLAB. So there's a lot of more I could do with this project. I'm really excited with AI in general, and this is a great stepping stone into AI, and I'm glad to present it with everyone. Thank you for listening to this video. I'm really proud of this project, and I'm glad to share it with you all. If you have any questions or concerns, please leave them down in the comments below and I'll try to answer them. In the description, I'll also add some links for some healthy websites and also my own code if you want to try it yourself. Thank you.